So in previous videos, we learned how to use this equation when analyzing circuits. And the way this equation works is if you have a circuit and you know the voltage source of the circuit and you know the total capacitance of the circuit, you can determine how much charge is stored on those capacitors. And that's what this equation tells us. So for example, for this circuit, we know we have a 10-volt battery. So the voltage of the circuit would be 10 volts. And we know the total capacitance of the circuit is 1 farad. So the capacitance of the circuit is 1 farad. So now we can determine the charge stored on the capacitors. So again, multiplying these, we would get 10 coulombs. So now we know 10 coulombs worth of charge would be stored on each of the plates of the capacitor. So that's how we use this equation. However, what if we had a different example? What if we had this circuit? If we had this circuit, how much charge is stored on these capacitors? Well, again, we know we can determine that using this equation. If we know the voltage source of the circuit, and we know the total capacitance of the circuit, that will give us the charge stored on the capacitors. However, what is the total capacitance of the circuit? If we have a 2 farad capacitor and another 2 farad capacitor in series, what's the total capacitance of the circuit? And what's that total capacitance of the circuit that we plug into this equation to find the charge on the capacitors? Well, again, the rule of thumb is essentially what you do is you redraw the circuit. You redraw the circuit with one capacitor that's equivalent to these 2 capacitors in series, where you would find essentially what these 2 capacitors are equivalent to. And then once you can find what these 2 capacitors are equivalent to, you can find the total equivalent capacitance of the circuit. So how do you find the capacitance of 2 capacitors in series? Well, the rule of thumb is using this equation. And essentially, it's the same equation for when we have resistors in parallel. So it's flipped. When we have these capacitors in series, it's the same equation as when we had resistors in parallel. And essentially, so if we have these 2 capacitors in series, let's say this is C1, capacitor 1, and let's say this is C2, capacitor 2. If we want to find what these capacitors are equivalent to, the equivalent capacitance, we can simply just use this equation. We would plug in 2 farad C1 here. We would plug in C2 here. And again, the same thing here. We would plug in C1 here and C2 here. And we would just solve this. So really it would be 2 times 2 divided by 2 plus 2. And then that would give us the equivalent capacitance. And if we were to solve that, we would have an equivalent capacitance of 1 farad. So having a 2 farad capacitor and another 2 farad capacitor in series is identical to having one farad capacitor. These are identical. They're the identical amount of capacitance. So now we know the total capacitance of the circuit. And again, we determine that using this equation. And this is another form of the equation you can use, where again, you can solve, there are these 2 ways you could solve for the CEQ, but I personally like to use this equation. But now we've done it. Now we've found the total capacitance of the circuit. The total capacitance of the circuit is 1 farad. So now using this equation, we can solve for the current, the charge stored on this capacitor. And again, if we were to do this again, we would do 10 volts multiplied by 1 farad, so we would get 10 coulombs. So that's the amount of charge stored on this capacitor, on each of these capacitor plates. But now, how does that translate to these 2 capacitors? Well, and this is just something you just need to memorize. This is just something memorized. Capacitors in series store the same amount of charge. So whenever we have capacitors in series, they store the same amount of charge. Where this capacitor would store 10 coulombs of charge on each parallel plate, and this capacitor would store 10 coulombs charge on each parallel plate. And we'll talk about this more in detail in the next video. So again, so now we solved how much charge is stored on these capacitors. So now let's do a different example. Let's say we have this circuit. And we want to find the charge stored on these capacitors. How do we do that? Well, again, we just use this equation. If we know the voltage of the circuit and we know the total capacitance of the circuit, we can determine the charge stored on the capacitors. But what is the total capacitance of this circuit? If we have a 1 farad and another 1 farad capacitor in parallel, what's the total capacitance? So again, we redraw the circuit with 1 farad, with 1 capacitor that's equivalent to having 2 1 farad capacitors in parallel. And the rule of thumb when you have capacitors in parallel is you simply just add them. It's pretty straightforward, and you can kind of imagine as this just being one capacitor. Just imagine these two capacitors next to each other. That you can kind of imagine it like that. But it's pretty easy. When you have capacitors in parallel, you simply just add them. So that would be 2 farads. So one 2 farad capacitor is identical to having 2 1 farad capacitors in parallel. And again, it's kind of the flip of having resistors in parallel. The equations are kind of flipped. But again, the point is when you have capacitors in parallel, you simply just add them. So pretty straightforward. And again, when we talked about capacitors in the previous video, you can kind of see why that's true. This is kind of like just having 2 1 farad capacitors. Like this one would kind of be like this one, and this one would be like this one. So again, it's kind of just like having these 2 farad capacitors right next to each other. So again, that's the rule. When you have capacitors in parallel, you simply just add them. Now we know the total capacitance of the circuit. The total capacitance of the circuit is 2 farads. So now with the little simple math, with this circuit has a 10-volt battery and a 2 farad capacitor, so this would give us 20 coulombs. So now that we know this capacitor will store 20 coulombs worth of charge on each parallel plate, 20 coulombs on this plate, 20 coulombs on this plate. But now, how does that translate to these 2 capacitors? Well, again, remember, it's essentially identical. This plate is essentially identical to having these 2 plates where this one is this one, and this one is this one. So if we know if this stores 20 coulombs, then this half would store 10 coulombs, so this half would store 10 coulombs. And this half stored the other 10 coulombs, so this half would store 10 coulombs. So now we know how much charge is stored on each parallel plate. And again, if you want more detail on what's going on, why do these 2 capacitors store the same amount of charge while these 2 capacitors share the charge? What's going on? I'll talk about that in my next video. I have a link of it below.